Hi guys, we're going to do 10.3 today. We're looking at something called a unit vector. Okay, so we'll get into what that is in a little bit, but let's start with some vocab here. I'm actually going to use the text feature on Kami, making a text box to fill in the blanks here. So just reviewing some vocab and then looking at a couple new terms as well. Standard position of a vector, we've talked about that before. That means that the initial point of the vector, so the starting point, is at the origin when we graph it, that we call that standard position. Component form of a vector is written as x comma y, okay, with our little pointy brackets, where x represents the horizontal distance that you travel, and y represents the vertical distance that you travel. And you're traveling from the initial point to the terminal point. Okay, we call it component form because it's the horizontal and vertical components that make up the vector. Okay, so those we're all familiar with already. We have two new terms today. The first one is a zero vector. And it's exactly like you would expect. It's a vector whose magnitude, so remember magnitude means the length, the magnitude is 0. Okay, we don't use those too much, but it's good to know. Other than a zero vector, we also have a unit vector. Thinking back to like the unit circle, that was a circle with a radius of 1. A unit vector is a vector whose magnitude is 1. Oops. Okay, so this guy, our unit vector, that's what we're going to use the most today. That's kind of our big focus, unit vectors, and calculating them, finding them. So here this box has why we're doing this. They're helpful in applications where you really care more about the direction, not the magnitude. They're definitely used in physics a lot because, believe it or not, when you see them, you'll be like, why? But they actually do make some complicated formulas a lot easier for people in physics. So again, we're just like scratching the surface, so we don't really get into too much of like the usefulness of unit vectors. Our job in pre-calc is just to expose you to what they are and help you learn how to calculate them. Okay, so let's start with that, finding a unit vector. It basically means we're scaling down any vector, so any vector length, so that it has a length of 1, but it's still going in the same direction. Okay. So the easiest way to do that is just to divide the vector, so this v here should actually be a vector v, by its magnitude. Okay, so we call the unit vector vector u. I don't know why all my arrows get messed up on here, but not a big deal. So u typically means the unit vector, and we can find that unit vector by taking whatever vector we start with divided by its magnitude. So remember, straight bars mean magnitude. Okay, let's say we'll call that vector v xy, like this. So if I'm going to expand this, instead of the symbol for vector, I'll write x comma y in our component form, divided by the magnitude, which we would calculate using Pythagorean theorem. This is kind of like multiplication by a scalar. Basically, I can distribute this division. So it's a big vector, x over the magnitude, comma, y over the magnitude. And we'll do some practice in a second. It's really not as bad as it might look from here. Okay. So let's use that formula. We'll find a unit vector. So here's our vector v. And then we're going to show that this is the unit vector because it will have a magnitude of 1. Okay, so step 1. If I'm going to find the unit vector, I need to know the magnitude. So I'm actually going to calculate that first. So we'll say find the magnitude of v. So I can do that with my Pythagorean theorem. Square root of negative 2 squared plus 5 squared. So square root of 4 plus 25. So the magnitude is root 29. Step 2. Then I'm going to actually calculate my unit vector. So we're going to call it u, vector u. So remember, unit vector is vector v divided by its magnitude. So here's my vector. So negative 2 comma 5 on top, divided by root 29. Now I'm just going to distribute that division. Negative 2 over root 29, comma 5 over root 29. Again, we don't typically like to leave radicals in the denominator of a fraction. Pretty easy to rationalize this guy. So I know that I would just be multiplying by root 29 on the top and bottom of each fraction. So I can do that pretty quick here. Negative 2 root 29 on top over just regular 29 on the bottom, comma 5 root 29 over regular 29 on the bottom. So there's my unit vector. And then the last step here is to just show that this unit vector actually does have a magnitude of 1. So this complicated looking vector and this nice vector here, they'd be going in the exact same direction. This one's just going to be a lot shorter. Okay, so let's find the magnitude of u. Same formula. So when I plug this in, I'm actually not going to use the rationalized one because that makes my life harder. Let's go back to before we rationalized. Negative 2 over root 29. Whoops. We're going to square that. Plus 5. Over root 29. And we'll square that whole thing as well. We're squaring the whole fraction. Now when you're squaring a big fraction, you can distribute the power. So becomes positive 4 on top. Root 29 squared is just 29. Plus 5 squared is 25. Root 29 squared is just 29. Adding fractions, they have the same denominator. 4 plus 25 is 29 over 29, which equals square root of 1. Square root of 1 is 1. So this is verifying, meaning we're showing that the magnitude is actually equal to 1. Okay. So we'll split this into two parts. So the last thing I want you to do here is to just find the unit vector yourself. Okay, so find the unit vector, just like we did in this last example, and then verify that it has a magnitude of 1. So pause the video, try that on your own, and then play the video to check your answer. Alright, so here's my answer for that problem. So first I found the magnitude. So remember when you're finding the magnitude, each component squared under square root. I got root 10. Finding the unit vector was next. So unit vector is vector v over its magnitude. So here's my vector, 3, negative 1, over its magnitude. I distributed the magnitude, the division. And then, so this is like an acceptable answer. This would be rationalizing it, like we talked about, delta math, things like that, standardized tests, whatever, you gotta rationalize. So here's my final unit vector. Honestly, I would take either one as an answer. And then verifying over here in step 3. So when you're verifying, go back to before you rationalize because the math is a little easier. When I square, I distribute to the top and the bottom. So I showed that the magnitude of this unit vector is equal to 1 like we would expect. Okay, in the next video, we'll finish up these notes.